A submarine is a remarkable underwater vessel designed to travel beneath the ocean's surface for long periods, using advanced engineering, physics, and technology to explore, observe, and operate in places where normal ships cannot go. Unlike surface ships that float because their hulls displace water, submarines have a special structure called ballast tanks that allow them to control their buoyancy, meaning they can float, sink, or stay at a fixed depth in the water. When a submarine needs to dive, its ballast tanks filled with seawater, making it heavier than the water around it. As the weight increases and the density becomes greater, the submarine begins to sink smoothly into the deep. When it needs to rise back up, high-pressure air is pumped into the ballast tanks to force the water out, making the submarine lighter and allowing it to ascend. This controlled floating and sinking mechanism is one of the most fundamental aspects of how a submarine works. Once underwater, a submarine uses hydroplanes, or diving planes, which are fin-like structures on the hull, to tilt the vessel up or down, helping it glide through the ocean at different angles. The movement of a submarine is powered by engines that differ depending on the type of submarine. Traditional diesel-electric submarines use diesel engines on the surface to charge huge batteries, then run quietly underwater using electric motors. Modern military submarines often use nuclear reactors, which provide immense power, nearly unlimited underwater endurance, and the ability to stay submerged for months without surfacing. A nuclear submarine can produce its own oxygen, purifying water from the sea, and maintain power continuously, making it one of the most self-sufficient machines ever built. Navigating underwater is another challenge, because GPS signals and radio waves do not travel well through deep ocean water. To solve these, submarines rely on sonar systems, which are like underwater eyes and ears. Active sonar sends out sound waves that bounce off objects in return, helping the submarine see its surroundings. Passive sonar listens silently for sounds made by other ships, submarines, or marine life, allowing the vessel to detect things without revealing its own position. Inside a submarine, the environment is highly controlled and carefully designed to support the crew's survival. Air is constantly recycled, carbon dioxide is removed, temperature and pressure are regulated, and fresh water is produced using onboard purification systems. Every inch of space is used efficiently because submarines are compact machines holding advanced electronics. Control rooms, sleeping quarters, kitchens, torpedo bays, and complex wiring. In military submarines, stealth is one of the most important features. Their hulls are shaped to minimize noise and avoid detection by enemy sonar. They move slowly and quietly, and their outer surfaces are often covered with special sound-absorbing materials. Some submarines carry torpedoes, cruise missiles, or even ballistic missiles, while others are used for reconnaissance, rescue missions, scientific research, or exploring the deep sea. Scientific submarines, also known as research submersibles, help scientists study underwater volcanoes, inspect shipwrecks, observe marine species, and map the ocean floor. These vessels often include robotic arms, bright lights, and high-resolution cameras to capture footage in the darkest depths. The deeper a submarine goes, the more pressure it must withstand. At great depths, water pressure can reach hundreds of times greater than the pressure at the surface. So submarines are built with strong, rounded hulls, made of high-strength steel or titanium, to prevent them from being crushed. The shape of the submarine also plays an important role in its performance. A smooth, cylindrical design with rounded ends helps it move efficiently through water and reduces drag, allowing it to travel faster and more quietly. Communication from underwater is limited because radio waves don't travel well through dense water. Submarines sometimes rise close to the surface and extend special antennas, called periscopes or masts, to send signals, communicate with satellites, or gather visual information. Modern periscopes are digital and provide high-resolution images to screens inside the vessel. Another important part of submarine operation is life support and safety. Fire, flooding, or pressure problems can be dangerous in a closed underwater environment. So submarines have strict safety protocols, advanced sensors, and emergency escape systems. Crew members are trained to handle mechanical failures, leaks, electrical issues, and navigation challenges. Despite the advanced technology, teamwork and discipline are essential, as every action inside affects the entire vessel. Today, submarines are symbols of human engineering and exploration. They serve militaries, rescue teams, scientists, and oceanographers, enabling humans to reach mysterious parts of the ocean that would otherwise remain unexplored. From silent nuclear submarines patrolling deep waters to small research submersibles studying coral reefs, these underwater machines represent a blend of physics, engineering, survival technology, and innovation. In simple words, a submarine works by controlling its buoyancy to dive or rise, using engines and hydroplanes to move, relying on sonar to navigate, and maintaining a safe environment for humans deep underwater. All of these complex systems work together to allow a submarine to travel quietly and efficiently in the hidden world beneath the sea, an environment full of pressure, darkness, and beauty that only a few machines are capable of exploring.